So once again, good afternoon and welcome to today's lecture. Let me share my screen. Of course, the lecture materials have been uploaded on our Google Classroom. I don't know if some of you have been able to download or, possibly review before now. If you are removed, try to join again, cassava in particular. So then, so the let me put it on. Oh yes. So our focus will be on logistic regression. I don't know if you have heard about regression before. Regression generally is used to establish relationship or to understand linear relationship between uh, between uh, a variable that is called dependent variable and other variables that are considered to be independent. So in which case, when we have variables, just a minute. So because some of you are just getting to know about analysis, maybe data analysis or statistics generally. Let's say, for instance, you believe that performance in mathematics, maybe you say the mathematics score, so math score is it depends on certain characteristics of the student, maybe the age, maybe also the
With you. Okay.
sorry, it's the network that is still misbehaving, but we'll get over it. So let's say we believe that a student's performance in mathematics is influenced by the age and then maybe the uh, the whether the student science student or art student. So which means the area of focus of the student. So these are factors that we believe will affect a student's performance in mathematics. So these ones that are factors, they are regarded as the independent variables. The one they are influencing, which is mathematics, will be the dependent variable. So regression analysis, so we usually represent the dependent variable by y, and then these other independent variables, we usually represent them by maybe x1, x2. So which means we can regress y on x1, x2. So regression tries to establish relationship between the dependent and the independent. Of course, we only mentioned two independent variables here. It's possible to have more than two. When we have only one, we say it's a simple regression, y on x1. When we have more than one, then we say it's multiple regression. Hello?
Yes, sir. I can't
Oh,
see your screen, sir.
no, sorry, I wasn't sharing my screen again. Sorry. And nobody talked. Thank you for letting me know. I'm going to repeat it again. So this is what I was saying. Can you see the screen now?
Yes, sir.
So what I said was that if we believe that your student grade in mathematics is determined by the age and also the area of specialization of the student or the faculty or whatever, the discipline or the focus of the student. So this one is the one that the mathematics is being influenced by these other two. So in that case, mathematics will be regarded as dependent variable. Then age and the area of focus or the discipline of the student, the two of them will be regarded as independent variables. So, and I said the dependent variable, we usually denote it by y. And the independent variables, we denote them by x1, x2, x3, and so on, if depending on the number of those variables. So those variables that are listed here are the variables that we believe are responsible for y. So y is the dependent. So regression, therefore, is a model, is a linear model, which simply expresses the linear relationship between the dependent variable and the set of independent variables. So the regression has different types. but it depends on the way this y is measured. There are two ways, basically, so that the y can be measured. As you know, if the y is measured on a continuous scale, so we say it is continuous. That is, it can take value within a range of intervals. So it's continuous. For instance, mathematics is measured, the score can be measured from 0 to 100. So it could be 40, 50, 60, 54.5, and so on. So that is on a continuous scale. The other one is it could be discrete. It could be discrete. So if it is discrete, then y can be a categorical variable. So maybe we say pass or fail. So we are not putting the exact score, but rather we are dealing with categories, and we've discussed about different measurements in the quantitative course. So if our y is measured in terms of pass, fail, then there are only two categories there. So in essence, y can be measured on a continuous scale, or it can be measured on a nominal scale, which is discrete. And that leads us to today's discussion. When it is measured on a continuous scale, then we say that we are dealing with ordinary linear regression, or we are dealing with the normal linear regression. But when y is measured on a nominal scale, is categorical like this. And specifically, if the categories, if you have only two categories, which we call binary, then we will be talking about logistic regression. So this lecture is focusing on logistic regression. That is the regression in which the dependent variable has only two categories, two classes. So, but we would also mention the fact that the categories could be extended. We could have situation where we have more than two categories, 3 or more. So that leads to multi-class classification. We will talk about that. But we have to provide this background because this is where we are going. And we want to be able to apply logistic regression, this technique, to be able to analyze sentiment, to do sentiment analysis. when dealing with text data. And to make it a little bit clearer, we are going to use this kind of data at the end of the day in our discussion. This is about individuals making comments. So let's say this is the this serial number of those who made comment on a movie they watch. There are 4 of them: the first person, the second person, the third person, the fourth person. And this is the comment of the first person saying, "I love this movie." Another person says, "This film is terrible." Another person says, "Amazing. Amazing performance by the actor." And the last one says, "This is the worst film I ever watched." So these are the comments from those from 4 individuals who watched the film. Now, here is the sentiment. And this is the label. So this sentiment is now attached. So, and there are 2 ways we can categorize these comments. So for the purpose of our discussion, we are using only 2 classes or 2 categories. So someone who says, "I love this movie," we can say the sentiment being expressed is positive. The one who says, "This film is terrible," the sentiment being expressed is negative. And the one who says this is the performance by the actor is amazing, that is also positive. So the last one, a worst film ever, says this is the worst film ever. This sentiment is negative. Now we can regard the sentiment here as our y, which is our dependent variable, because this sentiment depends on the comment. So we can regard this as x. I'm sure you are following me. I don't know. Are you
Yes,
following
sir.
me? Good. Please,
Yes, sir.
if you don't ask questions, I won't know whether you are following. So in that case, we have a dependent variable, which is y, and we have only one independent, in this case, the comment, and that is x. So when we have a dependent variable y like this, that is measured on 2 categories, that is when we can use logistic regression. Unlike when you have, let's say, you decide to look at the number of words, word count. When you look at the word count, and you say how many word count was used by this. Just a sorry for that. The word count for the first person will be 1, 2, 3, 4. So we have 4 there. So we can put 4 there. The word count for the second is 1, 2, 3, 4. 4. The word count for the third 1, 2, 3, 4, 5. The word count for the fourth one is 1, 2, 3. This is numeric, not category. So if, for instance, we want to analyze word count and comment, then since word count is measured on a continuous scale or as a count, we cannot use logistic regression. So we can only use logistic regression when you have your dependent variable in 2 categories, as we have here, which is comment either taking positive or taking negative. So this one is not the one we have in mind in this lecture. So if that is clear, then we come back to our slide. So first, I will try to make you to understand the fundamentals of the logistic regression for binary classification. Then show you how we can again extend this logistic regression to a situation when the categories are more than 2. For instance, we could also have people who will be neutral. So if we have another comment now that is neutral, then the categories will be either positive, negative, or neutral. And then there will be 3 categories. So that is when we are dealing with multi-class classification. So, and then we will now do hands-on and apply logistic regression method to this particular data that we have here, just for purpose of demonstration. So what we will do after this class will be to possibly look at any site. I can't see your screen. Adedeji, is it true for everybody? Adedeji said
I can see your screen, sir.
Adedeji, maybe that problem is local. So you will also choose any website or even WhatsApp group that you belong to, and bring the comments here. The first person who commented on it, the second, the third. So you create a data stuff like this, and then put the comment here, and then you state whether that comment is positive or whether that comment is negative. So that's what we also do. And then you will now be able to apply logistic regression to your own data and you can be able to analyze it. Is that clear, everybody? So let's move on to the definition, which already provided.
Please, sir, I did
Yes.
not get the instructions, sir. Thank you, sir. Could you recap it, please? Thank you very much. Can you recap what you say we should do, please? Thank you very much.
I said after this lecture, you will also generate your own data set, which might be much more than this. So you have, it could be on your WhatsApp group. It could also be about a film. It could also be about any of Twitter of your organization or of your department if you have one, and look at comments regarding the issues people commented on. It could also be about the recent book launch by the former president. So you can generate the comments, the first person, the second, the third, and so on. And then you can assign the sentiment here. So you have the data that you can use. Is that clear?
Yes, sir.
Great. So let's go to the definition which I've already provided. Logistic regression is a model. It's a statistical model. And we use it to predict, the probability of a categorical outcome. In other words, this is a typical categorical outcome. So sentiment is the outcome. The comments represent the independent variable or the explanatory variable, but I don't want to use all of that. In machine learning, which is what we are actually talking about, in machine learning, we will call sentiment the output. So we can also call this the output. So we can call it output. Then we call the comment, we call it the input. We also call it the feature. The feature. So you need the feature in this case, or you need the input, and then you also need the output. So remember that the output is the one that will be in category. Sometimes also this output is called the label. The label. So it means in this case, we have we can call positive as the label assigned to I love this movie. We can say negative is the label assigned to this film is terrible. So label, output, why they mean the same thing. So that can help you to understand. But when we talk about the input, the features. Those are they mean the same thing, but they are also generally independent. So this one, sentiment depends on them. So they are independent because these comments are made independently. Now, that's the definition. So the categorical outcome, another example here is if we are talking about emails. So we can also categorize them as spam or not spam. So which means if you have another data set which is not about comments, it could be here you could have, let's say, serial number, and then here you have the email, and then here you have the category. So which means the first email will be here, and then the content of the email will be here, and then which category, you can now say whether it is spam or not. Then you take the second one, then you put the email there again, and then here you indicate whether this is not spam. So again, email here will be a feature. So which is also regarded as input in this data. And then category will be, in this case, our label or our output. So this is another data that we have generated. But the fundamental thing here is that logistic regression is the model that can now help us to predict probability of a categorical outcome. And what that means is that in this case of sentiment, we are interested in the probability of somebody who watched the film, the probability of that person making a positive comment, or the probability of that person making a negative comment. Again, if it's about email, we are interested in the probability of the email being a spam, the probability of the email from this person not being a spam. So in essence, logistic regression helps to predict probability. Logistic regression helps to predict probability. And as you will see later, that probability is then used to categorize incoming email, for instance, or categorize an individual who watched the film, you can now predict the probability that he or she will make a positive or negative comment. So why do we use logistic regression? Now, I told you we only use it when we use it when we have binary classifications. That is, when the output or when the label have just two categories. Then we can also, another benefit of it is the fact that we are able to predict probability, or we can provide the likelihood. We can interpret our prediction in terms of probability. Again, as far as logistic regression is concerned, it's easy to, particularly with computer and other popular software, as you see, it's possible to interpret efficiently, and then the computational process is not so tedious. You can easily use the software. So what are the examples? I've given you an example of email classification. You can be interested in predicting whether an incoming email is a spam or not a spam. You can also be interested in predicting whether a review, a review of a particular film or a particular movie is positive or negative. And there are other areas where this can be applied. So this table simply helps to compare the difference between logistic regression and the linear regression. So here is the linear regression, here is the logistic regression. And I've explained before, the output, the output in the linear regression is continuous or numerical, whereas the output in the logistic regression is categorical, and I've explained that. But the equation is given for linear, it's a linear equation, and the linear equation simply expresses y as a function of, as a linear function of x. So, and it's written like this, y equals to beta naught. Beta naught is the intercept, beta 1 is the coefficient. So, but everything together is the linear equation. So x here is the dependent, in our case is the output, and y is the independent, in our case is the input or the feature that we talk about. For the logistics, so the probability is what is based on probability. So, so that's why you see probability, but you will see is equals to 1 all over 1 plus, this is exponent minus everything that you see here. So you can see the logistic regression as having even a component of the linear distance, as an exponent of the linear function. So this is the expression for the logistic, for the probability of y. Now, when do we use the linear regression? We use it when we are predicting numerical values. When our y is a number, like I mentioned earlier. So it's numerical, is measured. Then when do we use, example, for instance, house price, grade, score, anything that is measured, inflation, exchange rate, there are numbers and things like that. Income, expenditure, these are all numerical values. When do we use the logistic regression? When the dependent variable is in categories, is classification, is in classes, is in group, two groups for binary logistic regression. So that function that we use there is the sigmoid function, unlike this one that is the linear function. This one is called the sigmoid function. So the linear regression can take output in, the value can lie between minus infinity to positive infinity. But the sigmoid function can only take values between 0 and 1. And that is even the reason why is in terms of probabilities. We've discussed this before, that probabilities can only take in values between 0 and 1. So whereas the linear regression can take value from negative infinity to positive infinity, the sigma function can only take, can only take value between 0 and 1. So, and that is why the sigmoid function is used as a transformation. So it transforms any real number into a probability. So that is the function. So when Z is there, and you have Z here. So when Z is equals to a linear function, then you simply substitute Z here. So this sigmoid formula is the one that transforms the Z. It transforms the Z to a probability. Transform the Z to probability. So no matter what numerical value that Z takes, it will convert it to a value between 0 and 1. So if we plot the sigma function, you see as Z approaches infinity, then the probability approaches 1. Usually you have something like this. Maybe. So here you have 1, and then and then when you have you have your Z here, on this side you have your probability of, you have the probability on this side. So as the Z increases, so it's increasing on this side, you can see that as is getting to positive infinity here, then is approaching, is reaching out to 1. But as is moving towards negative infinity on this side, then the probability is getting close to 0. This is where you have 0. So this kind of plot is the sigmoid function. Don't worry yourself too much, but it's good that you have this theoretical background. So how do we interpret? So we interpret the probability by using it to classify the comment, or in the case of email, so when the probability is greater than 0.5, then we will say it is positive. Or we say the comment, the email is spam. So,
sir. Yes, sir.
Yes.
Thank you, sir.
Yes.
Sir, I think I'm lost too. I think I'm not following again. Thank you very
Where
much,
are
sir.
you
Please,
lost?
could you go back to the sigmoid function? I was actually following, but I think I lost at some point. Thank you very much, sir.
Okay. I use this graph to demonstrate the sigmoid function, which on the vertical axis you have the probability. This is the probability, and the highest value that probability can take is 1. The lowest value it can take is 0. The Z, interestingly, can take a value between minus infinity to positive infinity here. But I just simply limit it to the positive side. But it could take value from anywhere. So, but as the Z increases, which is what you see here, as the Z is moving towards the positive infinity, you will know that this curve is moving towards 1. Sorry. That curve is moving towards 1. So, sorry for this. So this is moving, the curve is not going to exceed 1. That's the point. It's not going to exceed 1. It's not even, in most cases, it won't touch 1. But as Z is getting towards positive side, then the value, the probability value will be rising. And as the Z is moving towards the negative side, let's say you are here, as the Z is decreasing, is moving towards this side, this curve will be approaching 0. But when it's increasing, it will be approaching 1. When it's decreasing, it will be approaching 0. So that's what these two statements are making. So if you understand that, then this is the way we interpret. It's never going to be exactly 1, no, in real life, no, and it's also not likely to be exactly 0 in real life. So we then use the probability. When we calculate the probability, when we calculate this probability, and it gives us a value that is above 0.5, then we will say it's close to 1 enough. And that if we are dealing with comment, we can say the comment is positive. If we are dealing with email, then we can say the email is a spam. If we calculate the probability, on the other hand, and the value is less than 0.5, then we will say it's actually moving towards 0. So if we are dealing with comment, we will say the comment is negative. And if we are dealing with email, we will say it is not a spam. So this is how this is the theoretical foundation for this. It's helpful. Who asked the question? Before I move to, I can't see the person again. Nobody is responding. Do I continue?
Yes, sir.
Okay, great. So we can now extend the logistic regression to when you now have more than 2 categories. So that's what we want. Supposing you, in the sentiment issue, you have 3 categories. The logistic regression can also be extended. So to a situation where you have positive, negative, and so this is positive, this is negative, and maybe when you have neutral. So you now have 3 categories. It can be, so when you have more than 2, when you have 2, then it's binary. When you have more than 2, then you are talking of multiclass or multinomial. So for binary, we are interested in predicting the outcome variable y when it is 1. Given the feature or given the input. So we've talked about conditional probability. We are predicting the sentiment when we are giving the comment. We can only predict the sentiment when the comment is given. We can only predict whether the category of email when the email is given. So that's what is being said here, that the output y or the outcome y must be known. In this case, we are we take the value to be 1. The 1 is which the particular category we choose as our reference category. So, but when we now have multi-class classification, like here, so we will be using an approach which we call one versus rest approach. One versus the rest approach, OVR. One versus the rest approach. And what that means is that if you have positive, you have negative, you have you have neutral, you have negative. Then, since there are 3, we have to have 3 sets of classifiers. The first one is to take the positive versus the other group, these 2 groups, neutral and negative. The other group will be, the second classifier will be the neutral versus the positive plus the negative combined. And then the third classifier will be negative versus positive and neutral combined. But we are not going to deal with this, only just for you to know that we can always extend the logistic regression to multi-class groups. And in that situation, we employ one versus the rest approach. So when we have been able to obtain classifier 1, classifier 2, classifier 3, we will now choose the class with the highest probability. So that will be the class that will be assigned to the one we are predicting. That's the group will be assigned to the highest probability. So use Softmax regression, which we are not also going to use. This one is used for modeling multiple class probability. So, but it's just for your notes, not that we are going to employ it. So you use this if your sentiment is in 3, if you are focusing on using positive, neutral, or negative sentiment. But in the one we are demonstrating, we are only using 2 categories, positive or negative. But in situation, if your study will require that you have up to 3 groups, then rather than using the sigmoid function, you use the softmax function. So let's go back to let's do the hands-on now quickly with our data. So I also share on the platform this script file. I'm sure you have also downloaded it. Now, the first thing to do, remember we are trying to use our data here. This is the data we are using for this demonstration. These are the comments, and which we regard as the feature, and this the label or the output. So we are trying to we are trying to use logistic regression to calculate the probability of individuals who watch the movie, the comments of individuals who watch the movie. So you need to install a package. We've been using this package before. So this is a text mining package. Then you also need to install this package called Caret. You could just, I've installed it. So Caret means classification and regression training. It's a very powerful package. So it can do regression. Regression, remember, here it refers to when the dependent variable is continuous. So it's saying you can use this package for both, the case of when the outcome is continuous and when the outcome is in category or in, is in is discrete. So it's referring to when it's in discrete is in categories. So you have those are two major packages you need to install. So in your own, if you have not installed, you need to remove this hash so that you will be able to run that. If you have it already, then you don't need to remove that hash. So we need to load the package after you have installed. So line 5 and 6 will help you to install if you have not installed. But to do that, you need to get rid of the hash there. So after you have installed, you can now load the text mining and the Caret. So it has loaded. You can see loading require natural language processing, and then you can also load this. Yes, so the applications have been loaded now. Then the next thing is to load and pre-process our data. We have our data already. So in line 15, we use the collector symbol here, which will help you to collect those comments. So it's going to collect the comments of the 4 reviewers. So each comment will be in a quote. It's in quotation, because it's text. I've told you before. So the second one is also separated by comma, is in quotes. The third one is in quotes, and the fourth one is in quotes. Then after you have put the features in this text underscore data, so it will store it there. For instance, if I run this now, you can even see the data by, so this is what is stored. The first one is, I love this movie. This is the second one. This is the third one. And this is the fourth one. Now, after we have stored the comments. We now need to store the sentiments. So that's what line 18 is going to do. So line 18, we will now use 1 to represent positive and use 0 to represent negative. Because if we don't do that, R will not be able to recognize that. So we use 0 and 1. So 1 for positive, 0 for negative. That's why here the first one ordinarily should be should be 1. So this should be 1. This should be 0. This should be 1. This should be 0. So this is what is collected now here and saved as label. So we can have this. If you want to see what is in it, you can see 1, 0, 1, 0. Now, you already know what corpus means. Corpus is a collection of documents. So we will now use the corpus function to be able to collect, to bring these documents together. So it will see this as a document, it will see this as another document, and so on. So we will be able to have 4 documents. So you use the corpus function and then use the vector source argument. So you can run this now. And if you want to see what is stored in corpus, you can see it. This is what is stored, telling you that you have 4 documents in your corpus. Then we need to do pre-processing, removing, converting them to lowercase, removing punctuations, getting rid of the stop words. Yes, Udo. Udo.
Yes, sir. Please, I want to ask about the labeling. If the data that we are labeling is much, like, are we going to hand label, like we label all the data manually, like saying positive, negative, positive, negative? If what we analyze, the data you're analyzing is up to 1,000 or 1 million, are we still going to label it manually? Thank you, sir.
No, you don't have to label manually because there are also, it's only I want to make it, I want the process to be clear to you. There are different sentiment dictionaries. Honey, do you want to explain to them that concept? Honey, are you there? Do you understand his question? Yeah, we are struggling to hear you, but go on, let's see if we can hear you better.
I'm on transit, sir.
Okay, don't worry. So, but
Thank you, sir.
the point is that you don't have to do it manually. Is that okay, Eddie? Udo?
Yes, yes, sir. It's
Yes. So there are already established. There are dictionaries for that have been that have uh, uh, that have been developed for categorizing words in terms of their sentiment, whether positive, negative, or neutral. Yes, Peter.
Good evening, Prof.
Yeah, good evening.
Sorry that I came late, sir. Udo, what Prof is saying is because we have this very small sample, it's easy for us to label by ourselves. But now imagine I have a very large, sample, plenty of data. Then it is inefficient to use this method. There are already libraries, there are solutions, there are packages. So, but we are taking it from these simple ones. Well done, Prof.
Thank you. So, if you want us to start from the complex, then we come back to the simple, that's possible. But it's good that you see things this way. And I also want you to do the stuff yourself. And that way you will be able to see what is going on, not just use existing libraries. You can also create your own libraries of word sentiments, which you can use. Because when you are dealing with different languages, not only English, if you are dealing with Yoruba, for instance, there are words that will connote different sentiments. If you are dealing with Ojo, Ojo, and so on like that, I know you know more than that. You know more than I do in that respect. So they could connote different sentiments. Even the pronunciation can alter the sentiment and so on like that. So it's good that you are able to create your own sentiment dictionary. Is that okay, Udo?
yes, sir. It's okay, sir. Thank you, sir.
Great. So as usual, we have to do the cleaning. We clean, we get rid of we convert them to lowercase, and then we also remove the punctuations. We also do away with the stop words. This is using the English dictionary, to address the stop words. That's why you see here. If we are using corpus, that in order, anyway, I don't want to emphasize that at this stage. So we have the corpus now that is clean. Let's even see the clean, if we want to see the clean corpus. Of course, we still have 4 documents in the clean corpus. So, but before we see it, let's create what we call document term matrix, which is done using the document term matrix function. So it will convert the corpus into a matrix form and then save it in DTM. So each row you have each document. So let's do that. Then if you want to see the document matrix, you can see it. This is only giving you the summary. So there are 4 documents there, and there are 9 terms there. You will see the 9 terms. All these other ones we will discuss their meanings later. Then we can now convert the document term matrix we convert it to data frame using as.data.frame function. So if we do that, first of all, maybe as a matrix before if you do it as a matrix, you then convert it to data frame. So you have that, and then you can see the data now. This is the data. These are the 9 terms now. These are the 9 terms. So this is love, movie, film, 3, 4, 5, 6, 7, 8, 9. So some words have been removed. High have been removed as not have been removed from that. You will also see that these have been removed. Is has been removed. So, for instance, in the first comment, you only have love, that is assigned 1. You also have movie, that is assigned 1. And all the other terms are not available in the first comment. No film, no terrible, no actor, no amazing. That's why 0 is assigned to them. In the second statement or second comment, you see love is not there. I only have this film is terrible. This has been removed. Film is still there. Is removed. Terrible is there. So we have only film assigned 1, terrible 1, every other one 0. The same thing happens to the rest. So this is the data, but this data, we have not yet included the sentiment label. That is, this label has not been included. So we need to include it to the data. And that's what line 31 will help us to achieve. So we will need to now run line 31. So we run line 31. So if you want to see the data again now, label will have been added. So you can see sentiment has been added. So you can see sentiment here, added to the data. So which means the data has been converted now to data frame, which can now be analyzed. And so to analyze using logistic regression model, we split the data into training data and the test data. So we will set the seed 1, 2, 3 for reproducibility purpose. So we run that. Then we will select a random sample we will randomly select the documents we want to use for the training set. So it will draw 3 out of 4, and then the remaining one. So that's what this one is saying. Draw 3 randomly. So it's going to draw 3. And if you want to see the numbers that have been the index, the training indices, which is, so it's going to select only, it's going to select 3. The document 3 is also going to select document 4 and document 1. So only document 2 will be used as test data. So you can run this, and then if you want to see the training set data now, you can see it will only pick 3, document 4, document 1. If you want to see the test again, you have to run line 39. And then if you want to see it, it will only give you only document 2. So this is where we are going. And this is where we would now use the training data to build the logistic regression model. Line 42 will help you to achieve that. And then you can now, of course, if you want to see the content of the model, you can see the content of the model, which will give you the coefficients. This is the coefficient for the intercept. This is the intercept. This is the coefficient for log, and so on like that. There are coefficients without value, so NA, no, but I don't want to disturb you too much on that. We are bothered more about the prediction. So we can predict using the model that we have. This same model can now be used for prediction, but we are only predicting. This is the model which is trained here, and then we will only predict using the test data. So we are predicting what will be the predicted sentiment for this second reviewer. So remember, the actual is 0, but we want to use our model to predict what the probability will have been, you know. So let's run this prediction, and let's see if we can even get the predicted value. So these are the predicted probability. You know. When you see all this, is because the data is very, very small. So don't worry yourself too much. And this probability is, so it's saying you have predicted the second, right? And then this is the probability. When you see this probability, it means you have 5.826215 exponential raised to power minus 11. So if you convert it to standard, standard number, that gives you 0.000000. So you have about 10 zeros before 5, which is 0. No, so we could also say that prediction is 0. So this line helps you now to classify. If the probability is less than 0, greater than 0.5, then it will label it as 1. If it's greater than 0.5, if it is less, as in this case, it will label it as 0. So if you run that, then you can possibly see what the predicted label is. So the predicted label for document 2 is 0. And that takes us to what we call the, we can create a table to compare the predicted and the actual. Of course, if we run that, so the predicted is 0, and the actual also is 0. That's what this table is. And I explained here. So if you run down to this place, yes, so this is the result that you see there. So it shows the performance of the logistic regression, which is able to predict the comment of the comment that was not used for training the model was, the one that we predicted. So, so this table represents the predicted versus the actual in the test data. The actual is 0, which is what you see here. The predicted also, so the actual is negative, which means the comment is negative, whereas the predicted is also negative. So this is the correct prediction in this case. So this table is what we call the confusion matrix. The confusion matrix. And I try to explain further what confusion matrix is. If you have yes, your model is supposed to classify, whether positive or negative. So this is let's say you have, this is the actual, this is the actual, which could be positive or negative. And your prediction also could be positive. Your prediction also could be positive or negative. So remember, this is prediction. So you have a table like this, which is showing here. It tells you how many you predicted to be positive and they are actually positive. So this one is called the true positive. Here is the, okay, let's come back. Let's come to this place. Here is the one you predicted to be negative and they are actually negative. Again, this is your true negatives. So any value here will be true positive. Any value here will be true negative. But if you predict positive, this is your prediction. You predict positive, but they are negative. They are actual negative. So we call this one false positive. So again, if you predicted negative, but they are positive, this is false negative. So whatever you have here is false negative. So it's only in this place that you have predicted correctly. But in these two cells, you have predicted incorrectly, wrongly. So you need to understand. So when we say, in this case, the actual settlement of the test is negative, which is 0, and the model correctly predicted it as negative, that's 0. So in this case, there is no false positives and no false negative. No false positive, no false negative. That's what it's saying there. So the model successfully classified the only case, in this instance as negative, which is correct. It doesn't mean it will always be correct. Don't go with that notion. So, but no prediction for positive 1, because of course we don't have enough data. We have no data for positive 1. So that's why there's no prediction for positive 1. And the reason is given here. So if this is a single test instance, we cannot generalize and say the model has done fantastically. So we need to have more data before we can really conclude that the model has done very well. So, but generally, it's not, we have other measures of performance. So the false positive tells you how often your model mistakenly predict positive for negative. And I think I've showed you. So, false positive, how often your model predict positive for negative. This is false positive. So your model predicts positive when it is negative. Whereas false negative gives you the number of times, how often your model mistakenly predict negative for positive. Again, this is the number. Your model predicts negatives when in actual fact they are positive. So, so we can talk about precision. Precision when you, so these are 3 measures which we'll talk about now: precision, recall, and F1 score, used to assess the overall performance of the classification model. Not only logistic regression, we can also use them to evaluate the performance of any classifier. I think the last class we discussed about naive Bayes, which we also use for classification. So we can improve this analysis by increasing the data, by checking the model bias, by evaluating the accuracy, which is what we love to do now. So we can calculate accuracy, we can calculate precision, we can calculate recall, we can calculate F1 score. So to do that, accuracy is the total number of correct predictions over the total number of predictions. So this is where you have correct prediction. You have here correct predictions. You have correct predictions. So the total over the value here plus the value here will give you the total correct predictions. And then over the total of everything overall. Let me demonstrate that here before we call it a day. Let's say you have this data. This is predicted to be 1, but the actual is 1, which means you have classified that it is positive and the actual is positive. So anytime you see 1, remember positive, no positive. When it's 0, it's negative. So this is predicted. These are the predicted labels, and these are the actual labels. We can use this data to generate a confusion matrix. So let's generate the confusion matrix, and let's print the confusion matrix. So this is the confusion matrix, which means for 0, when it is negative, sorry, when it is negative 0, and this is when it is positive. So see, the one on top represent the actual negative, actual positive. This is predicted negative. This is predicted positive. So 2 were correctly predicted to be negative. Sorry, were predicted to be negative when they were actually negative. 1 was predicted to be negative when it was actually positive. 3 was predicted to be positive when it was actually negative. And 4 was predicted to be positive when it was actually negative. Positive. So you have correct prediction here. You have correct predictions here. So there are 6 cases of correct predictions. Out of how many? 2 plus 1 plus 4 plus 3. So that is 10. Out of 10 predictions, 6 were correctly predicted. That gives you the accuracy, and that's how you get 0.6 there. But you can use formula to calculate that. So from this table now, you can get the true positives. The true positives. So if you run this, that will give you the true positive is 4. That's when you correctly predicted positive and they were positive. That's true positive. Then true negative, as you can also see, this is 2, but you can use this expression to get it. So which is 2. To get the first positive, that is 3. That is 3, and that is when you your model predicted positive when the actual was negative. And then the first negative is, of course, 1. So this formula can now help you to calculate accuracy. Accuracy is the true positive plus the true negative divided by the total of everything in that table. So remember, everything is 2 plus 1 plus 3 plus 4, which is 10. True positive will be, the true positive 4, true negative 2. So that will be 2 plus 4 divided by 10. That gives you the accuracy. And if you run that, you get this expression. For precision, is true positive. No, true positive is 4 over the true positive plus the false positive. That gives you 0.571. Recall is true positive divided by true positive plus false negative. That gives you 0.8. F1 score is 2 multiplied by precision, so you will have computed precision. So you will have computed precision and recall before you can compute F1 score. So with this expression, you get F1 score, which is 0.66. Interestingly, these results are also provided, when you run this function. After you generate the confusion matrix, this is the result. So you have the accuracy. There are other measures that are there, which we have not discussed. So you see the accuracy stated, which is 0.6. That tells you how the degree of accuracy of your model. So beyond accuracy, you can look at precision, recall, and F1 score. Finally, of course, this one is just to summarize the results as you have this. So giving you accuracy 0.6, precision 0.57, recall 0.8, and then F1 score is. Now, if again we decide with this same data, if we apply naive Bayes approach, then we can now compare accuracy and say, oh, the one with the highest accuracy will be considered as the best model. So you cannot really, except maybe you are comparing. So that's when you will say one model is better than the other. But you can have idea, from this result about the performance, of your model. So this is the summary, or this is the end of the lecture for today. If you have questions, yes, Udo. Udo.
Yes, sir. Thank you, sir.
Yes.
So I have a few concerns, sir.
Go on.
Because actually, I discovered that the note you shared to us doesn't carry all the lines of codes that I've seen on the screen, and I think I would like to practice along using the lines of codes if necessary. The lines of codes you presented, because the lines of codes on the notes on the PowerPoint are not that are not complete, if I should say that way. And that's the first concern.
Let me answer that. Which one are you saying? The codes are in the, this is the lecture note, and they are there. The lecture, are you with me, Udo?
Yes, yes, I'm there. I'm there.
These are the codes now, except the last part. And the last part, if you open this document, then you'll be able to see everything here. So you don't even need to type, you just need to run from this place.
Okay, okay.
So you need to download this second file.
Okay.
Okay,
And,
okay.
save it, save it in your working folder.
Okay.
Okay, so go on. Any other concern?
Yes, so sir, there's a serious another serious concern too. Sir, I don't know because at least I've been able to follow up the class to confusion matrix. When I go to confusion matrix, I got so confused. At that point of confusion matrix, I did not really get it, and I don't know. I don't know, sir, if possible that I don't know. This could be only my concern. I don't know if we could have some of the classes physical because I to some point I get confused when I'm following up. I don't know if there's a possibility that we could have some classes, some lectures physical because most of us are not from the computer science or coding background, and at some point there's a point of departure. So I don't know if there's anything we could do about that, sir. Thank you very much, sir. Thank you.
The truth of it is that if we do it physical, I may not be able to do the much of explanation that I'm doing here, because I could easily move across different applications as I use the Google Sheet, for instance. I use my PowerPoint, and I also use my R package. You think that will be easy if it's physical? So yes, I am fair.
Yes, sir. I agree with Udo. This kind of practical work, it will be a lot easier to comprehend in person, sir. Because while you are going through the slides, I had questions, but like I couldn't ask my question as you were explaining. So there were even points in time where I would forget my question, and I won't be able to like come back to. So I feel like even if it's just going to be one physical class, so we can summarize the entire curriculum.
Yeah, that's why I have my colleagues here to assist you. Peter is here, Honey is here. It's going to be practically difficult for me to also engage you both physically and online. So, but you can, they are available to assist you.
Okay, sir.
Great. Does that solve the problem? And the videos are also, they are there for you to watch. I know the challenge is the background, but again, you can't, you just need to do extra work to be able to flow along. Peter, are you still very much available for them? Honey?
Yeah, so we'll discuss with them and look at the possibilities.
Yes, sir.
That's great. Okay, so I think you should use the advantage of the colleagues that are available to support. But it's also not something good when you say you forget your question. You can always, I've always encouraged you to ask your question while the lecture is going on. You can always stop. And when I see anybody raising hand, I stop. Haven't I been stopping? And then beyond that, you can also type the questions. Again, you can write the question down, and when we finish like this, or before we close the meeting, you can ask the questions. Now we have question and answer time. You are free to ask questions. So, any other comments or question? If none, yes, edit them.
Yes, thank you very much, Prof. I'll just go straight to my question. My question is Bayesian classifier. How can we differentiate, or can we point out the similarities between Bayesian classifier and the logistic classifier? Thank you very much, Prof.
Both of them are classifiers. They are used for the same purpose. Only that the method, the technique, they are based on different principles, but they both aimed at achieving the same purpose, to classify, just as we have just done. I think the example we used in Bayesian was to classify spam email, if I remember correctly. The same way we can use logistics to do the same thing. And there are still other techniques that are classifier techniques. Is that okay, Eddie Young?
Yes, Prof. Thank you, sir.
Yes. So the only difference is the principle underlining their techniques, and that's the theoretical foundations that in the case of naive Bayes, we discussed about the conditional probability. I started with probability. I also explained the concept of conditional probability, the Bayes theorem. Some of those things, they are things you are supposed to learn. They will take you a lot of time, but I have to make them compact. Otherwise, we could be on even this logistics regression, we could be on it for 3-4 classes if I'm to cover it more in mathematically, and but I only focus on the the basic that you need for your understanding. So they are used, and we are still going to consider other techniques that next class. Now I think we'll be discussing about neural networks. So you should be prepared. I mean, you just have to do extra work and also find a way to relate with those who are in the quantitative backgrounds. Any other question? Cassava. I'm not sure I had. Yes, Cassava.
Yes, sir. I'm here, sir.
Huh?
I'm here, sir. I just have to read extra mile to get everything, sir.
You need to read.
And actually, while we are in class, I ran the code on R and I got the same result.
Of course.
I used the material you sent.
So
it's just the explanation that I was listening to.
Yeah, if you watch the video again, I think the explanation will be clear. That's why I prefer this virtual, because if I teach you, even if I teach you in the class, nobody is going to record it. And whatever I say there, you only depend on what you have jotted down. That's all. But this one, you can watch and pass it to your generation. I think you should develop a better mindset for this course, and then create more time to watch, to also take advantage of my colleagues here to provide necessary. Or if you have any issue, you can now come even to me. You can come to my office. Then I'll be able to clarify. I have not heard from Ghana yet. Is it that you are destabilized today? Ghanaiat, Lawa, these people didn't talk at all. Deborah, Ayanfe Olua. Okay, so.
Yes, sir. Hello, sir.
Hello.
Yes, sir. Thank you very much, sir.
Thank you, sir.
I'm not asking you to thank me. I'm asking you to ask questions and also let us know what you know and what you don't know. Okay, so I think we can start. Yes. Okay, Edidion.
Okay, Prof.
Yeah.
I actually want to ask if there are textbooks that we can, there are available textbooks that we can also consult that will also help us in, getting more understanding on the course. Thank you, sir.
Textbooks will probably confuse you more because if you take 10 textbooks, they will discuss in 10 different ways. But yes, you can consult. There are textbooks. There are textbooks that you can consult. But how they will help you is what I don't know. But I think you can easily get textbooks on logistic regression, even on the internet. I'm working on, you can also, on my YouTube channel, I have videos of other lectures connected to machine learning that you can watch there. Only that you people will not have the time. So if there is no other question, thank you. Then we meet on Thursday for 751. Until then, enjoy your week, the rest of the week.